Hi children, welcome back to the second module of the chapter Polynomial. Today we can discuss the relation between zeros and coefficients of a quadratic polynomial. Zeros and coefficients of a quadratic polynomial. So we know that the general form of a quadratic polynomial is ax square plus bx plus c. Then we already learnt a quadratic polynomial at most two zeros. So let alpha and beta be its zero. Let alpha and beta be its zeros. Let in general alpha and beta are the zeros of a quadratic polynomial. The general form of the quadratic polynomial is ax square plus bx plus c. Its general zeros, let it be alpha and beta. Alpha and beta are the two zeros of a quadratic polynomial. Then its factors are x minus alpha and x minus beta. Then we can factorize this polynomial into the form x minus alpha and x minus beta. If alpha and beta are the zeros of the given quadratic polynomial, the general form of the quadratic polynomial is ax square plus bx plus c, and whose zeros are alpha and beta. Then its fact is we can factorize the given polynomial into the form x minus alpha into x minus beta. The given polynomial is px, p of x, let it be ax square plus bx plus c, and its zeros are alpha and beta. Then its factors are x minus alpha and x minus beta. So we can generalize a relation between these coefficients a, b, c and zeros alpha and beta. It is alpha plus beta equals minus b by a, alpha beta equals c by a, alpha plus beta equals minus of b by a. B means coefficient of x, a means coefficient of x square. Sum of the zeros equals minus of coefficient of x by coefficient of a, and alpha beta product of the zeros c by a, constant term by coefficient of x square. Alpha beta product of the zeros equals c by a. C by a means constant term divided by coefficient of x square. Is in general, if alpha and beta are the zeros of a quadratic polynomial ax square plus bx plus c and a not equal to 0, that is understood condition, then you know that x minus alpha and x minus beta are the factors of this given polynomial. It can be factorized, or its zeros are alpha and beta, and sum of the zeros and product of the zeros we can relate to the coefficients a, b and c. For example, on small example, 2x square minus 8x plus 6. So it can be after the factorization we can find the zeros that we already learned class 9th. So the two zeros are x is equal to 1 and x is equal to 3. X is equal to 1 and 3 are two zeros of this polynomial. That means alpha equal to 1, beta equals 3, alpha and beta are 1 and 3. So we conclude, we can verify the relationship. The sum of its zeros, sum of the zeros, alpha plus beta 1 plus 3 equal to 4. That this 4 is equal to minus b by a, minus of minus 8 by 2, it is 4, and product of its zeros equal to 1 into 3, 1 into 3 means 3, it is c by 8, 6 by 2. This is the relation between zeros and coefficients of a polynomial. Hi children, your CBSE textbook exercise 2.2, the first question is find the zeros of the following quadratic polynomial and verify the relationship between zeros and coefficients. These are for there 1, 2, 3, 4, 5, 6 questions are there. See these questions we can one by one we can practice. One question is 6x square minus 3 minus 7x. First we can arrange this quadratic polynomial into the standard form, the general form. General form is ax square plus bx plus c form. That means 6x square minus 7x minus 3. So we can factorize this polynomial. We can factorize this polynomial into the product of two linear polynomials. Now it is a quadratic polynomial. This quadratic polynomial we can factorize into the product of two linear polynomials. They are 3x plus 1 and 2x minus 3. That means 6x square minus 7x minus 3 equal to 3x plus 1 into 2x minus 3. See, we have to find its zeros. So we can equate each linear polynomial into 0. 3x plus 1 equal to 0. That means x is equal to minus 1 by 3. 2x minus 3 equal to 0. Therefore, x is equal to 3 by 2. Therefore, the two zeros are minus 1 by 3 and 3 by 2. Therefore, two zeros are minus 1 by 3 and 3 by 2. Now, we can verify the relation between these two, these alpha and beta, and the coefficients a, b, z. Here the coefficients are 6, that means a equals 6, b equals minus 7 and c equals minus 3. Now, sum of the zeros. Now, the zeros alpha beta are minus 1 by 3 and 3 by 2. Sum of the zeros minus 1 by 3 plus 3 by 2, that means 7 by 6. This 7 by 6 we can express in such a way that minus of minus 7 by 6, minus of minus 7 by 6, that is minus of coefficient of x by coefficient of x square, minus of minus 7 by 7 divided by 6 minus b by a, and product of the zeros, that means the zeros are minus 1 by 3 and 3 by 2, minus 1 by 3 and 3 by 2, their product minus 1 by 3 into 3 by 2, that means minus 1 by 2, because 3 cancel, minus 1 by 2. This minus 1 by 2 means c by a, c minus 3 by 6, minus 3 by 6 means constant term by coefficient of x square. So, what we have seen, see ax square plus 6x square minus 7x minus 3, that quadratic polynomial is 6x square minus 7x plus minus 3, and its zeros are minus 1 by 3 and 3 by 2. Sum of the zeros equal to minus of coefficient of x by coefficient of x square, product of its zeros. The product of the zeros means constant term by coefficient of x square. Thus, we verified, that means the verified minus b by a, sum of the zeros alpha plus beta equals minus b by a, alpha beta equals c by a. That concept we verified in the problem 6x square minus 7x minus 3. Here the next question is 4s square minus 4s plus 1. So, another quadratic polynomial in the variable s, 4s square minus 4s plus 1. We can factorize this polynomial into 2s minus 1 whole square. So, identity a plus b whole square, a square minus a minus b whole square, a square minus 2ab plus b square form, because 4s square minus 4s plus 1. So, it is 2s minus 1 whole square. 2s minus 1 whole square means 2s minus 1 and 2s minus 1 are their factors. We can factorize 4s square minus 4s plus 1 into 2s minus 1 into 2s minus 1. We can equate 2s minus 1 to 0. So, s is equal to 1 by 2. S is equal to 1 by 2 means the zeros are 1 by 2 and 1 by 2. The zeros are 1 by 2 and 1 by 2. Therefore, two zeros are 1 by 2 and 1 by 2. Now, sum of the zeros, the alpha and beta are same zeros. Alpha and beta are respectively 1 by 2, 1 by 2. Sum of the zeros 1 by 2 plus 1 by 2. Half plus half, it is 1. 1 by 2 plus 1 by 2 equal to 1. 1 we can express in such a way that minus of minus 4 by 4, minus of minus 4 by 4, that means minus of coefficient of x, s by coefficient of s square. Minus b by a form we can express. Similarly, product of the zeros 1 by 2 into 1 by 2, 1 by 2 into 1 by 2 equals 1 by 4, 1 by 2 into 1 by 2 equal to 1 by 4, 1 by 4 equal to c by a, 1 by 4 c by a. So, constant term by coefficient of x square. The next question is 4u square plus 8u, 4u square plus 8u. The quadratic polynomial in u, only two terms are there. Here constant term is missing, no problem. 4u square plus 8u, how can we factorize? That means general form, first we can convert it into general form. 4u square plus 8u, constant is missing, means let it be 0. 4u square plus 8u plus 0. That means how to factorize this? Factorization already we learned in class 9th. That means first two terms. 4u outside, 4u into u plus 2. Now, this product, how to find its zeros? Equate to 0. 4u plus u plus 2 equal to 0. 4u plus u plus 2, a product AB equal to 0, 0 factor theorem. A product AB equal to 0 means either A equal to 0 or B equal to 0 or both equal to 0. That means a product AB for U, either for U equal to 0 or U plus 2 equal to 0. In case for U 0 means 4 will not be 0, so U equal to 0. U plus 2 equal to 0 means U equal to minus 2. So, two zeros are alpha and beta, like the two zeros are 0 and minus 2. Two zeros are 0 and minus 2. Now, we can verify the relationship. Sum of the zeros means 0 plus minus 2. 0 plus minus 2 means minus 2. Minus 2 we can express in such a way that minus 8 by 4 minus 8 by 4 minus b by a form, that means minus coefficient of u by coefficient of u square. Now, product of the zeros. Product of the zeros means these two zeros, their product 0 into minus 2. 0 into minus 2 means 0 into any number is 0. So, it is 0. 0 equal to this 0 we can express 0 divided by 4. Constant term by coefficient of u square. This is a relation between zeros and coefficients. So, the relation is verified, that is all. Hi children, the remaining questions of this exercise you can practice by yourself. Now, the second question, find a quadratic polynomial each with the given numbers as the sum and product of its zeros. So, what is given in these questions? Sum of the zeros and product of the zeros, alpha plus beta and alpha beta are given. We have to form a quadratic polynomial. We have to find the quadratic polynomial whose zero sum of the alpha plus beta is 1 by 4 and alpha beta is minus 1. This is the first question. Then we have to find a quadratic polynomial. What was that quadratic polynomial? Like that 1, 2, 3, 4, 5, 6 questions are there. We can check one by one. The first question is 1 by 4 minus 1. That means alpha plus beta 1 by 4, alpha beta is minus 1. We have to find the quadratic polynomial. Let the polynomial be, quadratic polynomial be ax square plus bx plus c and its zeros be alpha and beta. This is the one, that is what we have to calculate, find. Let the polynomial be ax square plus bx plus c and its zeros be alpha and beta. What is given? Alpha plus beta is 1 by 4, alpha beta is minus 1, 1 by 4 and minus 1. We already verified the previous section. Alpha plus beta means it is minus b by a, alpha beta means it is c by a. That means 1 by 4 equals minus b by a. Minus 1, this minus 1 we can express in such a way that minus 4 by 4. Minus 4 by 4 means minus 1. So, minus 1 equal to minus 4 by. Minus 4 by 4 equal to c by a, 1 by 4 equal to minus b by a. We can compare these two fractions. 1 by 4 equals minus b by a, minus 4 by 4 equals c by a. So, clearly a equal to 4, minus b equal to 1 and b equal to minus 1 and z equal to minus 4. So, a equal to 4, b equal to minus 1, z equal to minus 4. Therefore, these values we can substitute there. So, the quadratic polynomial is ax square 4x square, bx minus 1 into x minus x plus c minus 4. That is the quadratic polynomial. This is what we have to find. The next question is root 2 1 by 3. So, like the previous question, here also we can start let the polynomial be ax square plus bx plus c and its zeros be alpha and beta It's given alpha plus beta equal to root 2, alpha beta equal to 1 by 3. Root 2, but we know that alpha plus beta equals minus b by a, alpha beta equal to c by a. Both case the denominator must be same, then only we can compare. So, here 1 by 3, here it is root 2 by 1. So, making the denominator same, multiply both numerator and denominator by 3. So, at the same time alpha plus beta equals 3 root 2 by 3, alpha beta equals 1 by 3. So, alpha plus beta means it is minus b by a, alpha beta means c by a. 3 root 2 by 3 equals minus b by a, 1 by 3 equals c by a. So, a equals 3, b equals minus b equals 3 root 2 or b equals minus 3 root 2 and c equals 1. So, we can substitute these values here. So, in this equation we can substitute. So, at the end the conclusion is therefore the quadratic polynomial is 3x square minus 3 root 2x plus 1, that is all. the next question is 0 root 5. 0 root 5, that means alpha plus beta equals 0, alpha beta equals root 5. Like previous question, we can start. Let the polynomial be ax square plus bx plus c, and its zeros be alpha and beta. Zeros be alpha and beta, and polynomial is ax square plus bx plus c. So what is given? Alpha plus beta equals 0. That means let 0 be 0 by 1. And alpha beta equals alpha into beta, alpha beta equals root 5. Root 5 equal to root 5 by 1. This is 0 by 1, this is root 5 by 1. Now we can compare with the relation between sum of the zeros and coefficient of the quadratic polynomial. That means 0 by 1 equals minus b by a. Root 5 by 1 equals c by a. So it is clearly a equals 1 and minus b equal to 0, therefore b also 0. At the end, c equal to root 5. So a equals 1, b equal to 0 and c equals root 5. Therefore, the quadratic polynomial is a means 1 into x square, b means 0 into bx plus c equals root 5. So the quadratic polynomial is x square plus root 5. The next question is 1, 1. Children, here the two zeros are alpha and beta, both zeros are 1 and 1. Let the polynomial be ax square plus bx plus c. Its zeros be alpha and beta. Zeros be alpha and beta. So given sum of the zeros and product of the zeros, they are respectively 1 and 1. So alpha plus beta 1, alpha into beta 1. This we can express 1 by 1 and 1 by 1. 1 by 1 equals minus b by a. Here also 1 by 1 equal to c by a. So now this is very easy, one of the easiest question in this section. So clearly a equals 1. B minus b equal to 1 means b equals minus 1, c equals 1. So these values we can substitute in the given quadratic polynomial. That means the recurred polynomial is ax square. A means 1 into x square, that is x square. Bx minus 1 into x minus x plus c equals 1. So the recurred polynomial is x square minus x plus 1, x square minus x plus 1. Okay, I am going to wind up this module now. Okay, we will meet again in the next class.